So what's up guys, and today I'm back with another video, and today we're going to be doing a secure network boundary using NSP in a scenario in Kubernetes code. So let's get into it. First of all, if you don't know what NSP is, an NSP is known as a network policy, and is when you define how you define how pods are allowed to communicate with each other, and if they are even allowed to communicate with each other, how. So like what other type of boundaries and stuff like that. This is just not on how pods. This can be also other network endpoints in your Kubernetes cluster. So a simple example is in this scenario how we're going to be setting up a website, and we're gonna just test it out and see if it works, and we're gonna just like wget it and see it does work, and then later we'll be applying a network policy which will basically deny any traffic coming to that website, and it will just cut it off. So even if you try curl the website wget it, it will just leave you hanging. It won't respond back, and that's how we're gonna do and learn how to deny all traffic to an application that we have set. So first of all, let's read the overview. So as you have seen, in some scenarios and in general, Kubernetes comes with a flat network schema. This means if you want to create network boundaries, you'll need something called a network policy with the help of CNI. So CNI stands for Container Network Interface, and you'll learn about it more later in the video when we actually need to set it up before doing the scenario itself. And in this scenario, we'll be looking at a simple use case on how you can create a network policy to restrict traffic and create network security boundaries between these Kubernetes resources. So this is a simple diagram on how it works. So with the Kubernetes node, and we're a product container, and we're trying to get at this default namespace app which we have created called website. And first we see at the first request we has sent, but then this goes here, but then the app website goes to the API server, and it gives us back with the deny. So it won't give us any result back. We can see if it's active, but it won't give us any result back. So yeah, that's basically how it works. And this is the YAML file, basically the network policy, which we'll be using to stop all traffic to this application. So by the end of the scenario, we will understand and learn the following. We will learn to work with network policies in Kubernetes clusters, understand and work with basic Kubernetes kubectl commands, and interact with pods and services, creating and destroying Kubernetes resources, and restricting the traffic using NSP. So let's just get into it. So see you guys then. So to get started with the scenario, it says here we have to please ensure that you're using a networking solution that supports a network policy. So here, actually getting started with the scenario is actually much longer than actually the scenario itself. So here, if you scroll down to the bottom page here, it says Kubernetes network policies. So I just want you guys to click that, open that in the middle, and this is basically the network policies and stuff. So to actually implement these network policies, we need to have a network plugin, and to use network plugins, we must also have a network solution which supports the network policy, as it's said here. Just right click and open that in a new tab here, and you see the Kubernetes 1.27, I believe that's the current version, supports container network interface. So we need to actually install this. It's a network plugin, and here it says installation here is just installation should be pretty simple here. So I'm just gonna right click and open this in a new tab. So this takes us to GitHub. Alright, so I'm going to open this up. So this is basically the GitHub. It's you should just be able to access it with the same here. I'm pretty sure they're the same. Yep, they're the same. So here, this is the CNI. This stands for Container Network Interface, and this is basically the network plugin, which will allow us to use this network policy and implement these network policies. So I just want you guys to scroll down here, and you see Container Network Interface. You can redo this if you want, and I want you to scroll down and
basically go to how do I use CNI. So the requirements are the reference plugins. So these reference plugins are basically also needed for CNI to work. So the CNI project maintains a set of reference plugins that implements the CNI specifications. Note the reference plugins used to live in this repository, but then split out into a different repository. So here, these are the reference plugins, and we also have to install these. So open that in a new tab. I've actually already opened these here, so this is it. Here, these are basically all the plugins, the main interface creating plugins, blah blah blah, stuff like that. So these are, you see here, build Linux, build Windows. They've got these both. So I'm going to be using build Linux because I have a Linux machine. So here, first we need to declare both of these repos because we are going to be using the CNI GitHub repo later on. So go to your attacking machine. I'm going to do this in the cd opt folder. Here I'm going to do sudo git clone and Kali, and we see we've got the CNI CNI repo. Here now we need to go ahead and actually. So now we have to go ahead and actually clone the plugins repo too. This is needed for the installation. So sudo git clone and the plugins repo. Wait for this to load. Now what we can do is now cd into the plugins repo, and we see here there's a build linux.sh, and this is what I would want to run here, obviously because I have a Linux, and this would build all the plugins needed to create CNI. So if we actually go back to the CNI documentation here, scroll down a bit into how do I use CNI, it does say in the reference plugins to build and install the reference plugins. So let's just do that real quick. So build Linux sh. Careful, you have to actually, I recommend you guys to do this in you do this as root, and do that again, and it should work. And this is just gonna build all the plugins needed for the CNI. This won't take long, so I guess just stay tuned. So I think we're basically at the end. Yep, so we've done that, and now we've basically built all the plugins needed from the plugins Git repo. So here now I want to go back to the website, and we've installed that, and now we want to actually run the plugins itself. So here we've installed, and we can do that with the privnet run sh, which is in the CNI, and also the docker sh scripts in the CNI repo. And here start out by creating a net config file to describe a network. So we need to do this before running them. So copy that, and what this command does is just makes a directory called net.d in etccni. And now this is actually the the network configuration. So paste this in, and sometimes you might get an error like this, so just be careful, and copy that again and just paste that in too. Paste it in, now press enter, and yep, so that's gone to my net config in the etccni, and this is also something you also need, so copy that and paste that in too. So after that, we now can actually go back to the website, and now we can go ahead and try see if now next we need to actually build the plugins we've already done this, but for the go part I recommend you guys to do this. So because we've already built the plugins, we can just set the variable go path to it, so we don't get any errors in the future if we are going to do anything. So opt plugins, this is the directory to plugins, and I've done it in the opt folder obviously. And here now what we can do is also do a CNI path, and now we're finally using the private net run sh for ifconfig. So here just copy the CNI path thing over there, paste that in, and this is obviously the plugins bin. So again, it's just the plugins directory. So for me that's an opt, go back, and now what we want to do is actually cd to the CNI scripts here. So go to your tech machine, paste that in, and basically put the directory to CNI, which is opt for me. Now we're in opt CNI scripts, and here we see the private net run sh and docker run sh. So here what we can do is go ahead and do sudo CNI path equals a CNI path private net run sh if config, and this will basically, this is supposed to return our private network configuration here, and we see in the Ethernet inet we get it back here. And if we do normal if config, we see it's completely different from the Ethernet that I have on this. So it is in our private network. So here, now what we can do, we can also do the Docker version here, because I just like doing both because I'm running also Docker in my Kubernetes. Here, if you press enter, BusyBox, if you don't have BusyBox installed, it will just pull the image for you. But you see here, we get the same results here back. So now what we can do, we basically finished installing CNI, and now we can go ahead and actually start basically installing these network plugins here. So we installed CNI, and now we, to actually isolate the Kubernetes cluster, we need something called a network plugin, and here there's loads of plugins like Calico, Cilium, Weave, Romano, but I'm doing Calico right now because it's the easiest, and there's a quick start way to do it on Minikube, and that's what I'm running right now. So quick start for Calico on Minikube, and here you can just scroll down and create a single node Minikube cluster. So that's a Minikube start with the network plugin CNI and CNI Calico. So I actually highly recommend you guys not to start your server, not to start your cluster, and actually start it through here, through the network plugin, because it will actually give us accessibility to the server scenario later on. So I just did kubectl get pods to see if any of my pods are running, and I believe that I don't have a cluster up and running, so it should basically just like lag out or not give me anything. So copy that Minikube start network plugin CNI Calico, and go back and see here it's just lagging, which means I probably just don't have a pod cluster up and running. So do paste that in, and we see here we're gonna an error because we're not supposed to run Minikube on root. So exit out of that and paste that in again, and now this would start running, and this will basically just create a normal cluster just with the Calico pods in a namespace. So yeah, so that's what it will do, and this will basically make us able to do the scenario. And we see here we can also watch the Calico pod after the cluster is running, and see if it's how long it's taking to run up. So it's basically verifying the Calico installation here by using the watch kubectl get pods command. So here now what we can do is just wait for the cluster to be running, and yeah, so I might see you guys when it runs. So here we see the cluster is spun up and basically configured a normal Minikube cluster just with the Calico pods in one of the namespaces. I believe it's a kube system namespace. So now we can go ahead and copy the command, which basically will watch the pods here. We'll watch the Calico pod, and what this gives us is, we're just looking at it if it's gonna spin up properly or not. Because if we get an error, that obviously means that we have some issue, and we see here pretty fast and it runs up. So the Calico pod has successfully run up, and now we can go and continue on with our scenario here. So just make sure to go into the Kubernetes goat directory and do a bash setup Kubernetes goat sh, and this will basically get all the pods running for this scenario. The reason I didn't do this first is because we needed to actually start the cluster with the Calico pods, so we can actually continue on with this scenario. or I usually just get this up and running before the video starts actually. So yeah, so here now we can do kubectl get pod, and we see they're creating, and now we're back and they're finished running here. So now what we can do is actually go back to the website and scroll up, Kubernetes Go, and now we have to we've set up the network solution that supports network policy, and we see the goal here is to create a network policy drop access to the website service. So here now let's run an Nginx container app website and expose it via port 80. So this will just expose port 80, and it's a simple Nginx website here, and this is a website that we're going to try to drop access to. So that has been created, and now we can just go back to the website, and now we want to actually just make a temporary pod to make a simple HTTP request to the website service we are running. So this will basically give us a temporary pod request, and paste that in, and this will just wait for it to come back for us, and this will just give us a temporary pod, and so we can quickly do a HTTP request to see if everything's running. And yeah, we see here we do get the result back, and that's the thing we were supposed to get because we haven't set any configurations to the website service itself, so that's good. Now we can go back, and now we can go to the network policies here, and we see if we just scroll down a bit, we have these default policies which will default deny all ingress traffic, allow all ingress, and these are just simple policies, and obviously that's what we want, right? We're just trying to deny and basically block all the traffic coming to the website. So here there's a simple YAML file already there for us called website deny, and this is basically, I'm just going to walk you guys through. It's a network policy API version. The name is website denied. That doesn't really matter, but what matters mostly is the app itself. The app equals to website, so we know, so it knows that we need to actually just stop traffic coming to this service, this app, instead of all of the other apps or stuff like that. So yeah, we see here this copy this and go back, and now just do gedit website deny YAML, and I just pasted this in, save that and quit it. And now what we're going to do is a kubectl apply tag f website deny YAML, and this will basically apply the YAML file that we just created, and we see it has successfully worked. Now we can try get the temporary pod again, and see that we can just do wget, and we see here it's just lagging, so that's good because we've told it to just drop all requests and block them, but this is just going to be running forever until it gets a request back. So here what we can do is actually do with the timeout of 2 seconds. So we'll wait 2 seconds, and we see here now download has timed out, so this means that we successfully denied all traffic coming to this service that we have up and running. And yeah, so that's basically the scenario. It's basically what we're supposed to do in this scenario, and basically how we can use network policies here to stop this, stop people from accessing that service. So yeah, so we can just delete all these applied resources, copy that, and this will basically delete everything. So make sure you exit out of your temporary pod that we have running up, and delete, and this will basically delete all these resources that we don't really need anymore after we finish this scenario. So here, let's go up, and that's basically how we can secure network boundaries using the NSP. And yeah, so that's basically the video up. So see you guys next time. Peace.